Hey, thanks for coming to my presentation. Nice to see so many people here. My name is Heikki Pulkkinen. I'm a data scientist at a company called VR. Now, if you were looking for some virtual reality stuff, I think you are in the wrong room. We are not, even though the company is called VR, we are only working with railway traffic. So I don't know if there's so many people present here, maybe someone could have made this mistake that has happened to us before. But okay, let's get to the topic. I would like to show you one use case of machine learning we did in our team and put to production, and what we learned from the whole process. How should you manage this kind of process of getting a new machine learning model and getting some value out of it? So what we wanted to do is to predict the number of passengers on each train. And well, this prediction can be used for many things. The first thing is that we should have the right amount of conductors on the train. So we have this rule that if there's less than 300 people on the train, one conductor is enough. Then if there's between 300 and 600 people, then we should have 2 conductors and so on. Also, we should get the right amount of wagons on the train. Of course, with the conductors, you can even 2 days before the train departs, you could get an extra conductor there. But if you want to add an extra wagon, you should make this prediction like, I don't know, 2 months before the train leaves or something like that. And also, this kind of model could be used for revenue management. So if we have a case where one train is going to be fully booked, then probably we should already increase the price to kind of get a little bit more value out of it, and maybe kind of also make sure that we have more tickets for sale closer to the departure. But actually, for revenue management, you need to build slightly different models, predict a slightly different output than here, but maybe the same code can still be used for that. Okay, so how do you predict the number of passengers? There's maybe 2 ways to look at the main data. Here on the left, you have the history of the trains that have already departed. So you are here, and you are trying to predict this day here. You can see a kind of clear weekly pattern. Every Friday and Sunday, there's a lot of passengers. Then on Saturdays, there's a little bit less. So probably when you are trying to predict this Saturday here, you should use this value from the previous Saturday. That's what we call the kind of the previous comparable date, the same day of the week and the same train and so on. And here you could maybe fit an ANOVA model. That would be the first thought probably when looking at this kind of data. But in addition to this, what we also have, we have data on tickets that have been already sold for the train that is leaving a couple days from now. So you could also kind of look at this curve and then try to predict where it's going to go. I don't really know what the kind of best model here would be, but maybe you could kind of check what the shape of the curve usually is and then kind of fit the similar curve to kind of the data points you have. And well, if you just, I spent a lot of time thinking about this data and the structure, and then thinking the ANOVA models and how to combine these 2 approaches. And then I came up with some how Amazon does this for their products, and they were using sequence-to-sequence neural networks, and that sounded really fancy and all this. But I think you can easily get lost if you make it too complicated. So what you really need to do is keep it simple, stupid. And then I came back to what I really need. Like this is the format of the table that I need to give the predictions in to the kind of business applications we had. So maybe I should start with this. So here we have the train number and the day the train leaves, and then there's also a different amount of passengers for each station-to-station interval. So this is the kind of departure station and arrival station, and then the kind of there's another arrival station or kind of all the different stops of the train. And then you calculate how many passengers we had for this train in the history data set. It's not that simple to calculate that either, because there's all kind of, like, of course, there's the basic people with the normal tickets, but then there's also series tickets and season tickets and some people who are allowed to travel the train without a ticket for one reason or another and so on. So just calculating this column right took like a couple of weeks. Okay. But then, if this is the format we need, then how can we make these predictions? Well, what we need here is some features. So first, we add one column to tell that on which date we are trying to do this prediction. So that's what we call the prediction date. And then we get features which were available on that prediction date. So for example, here we are trying to predict it 6 days before the departure, maybe we can use that as one of the features, how many days there are to departure. And also we can get a feature of how many tickets were sold by that date. And also how many tickets were sold on the previous Saturday, as you saw on the graph before. You can get features from both of those approaches, and I think that's what's the best strength of this approach is that you don't really need to choose if you want to use the booking curve or the sales history. You can kind of get both here. Right, so okay, here's the only formula I'm going to show you. It's pretty simple. So here we have the features, the x, and this is the y we want to predict, and we want to fit the function to kind of get it as close to the kind of actual y as we hear. So basic regression, nothing special. I chose to do this with extreme gradient boosting. The reason is that I didn't need to do much hyperparameter optimization that way. Like I could just take the basic model, and it worked pretty well. I just added more estimators. The more I added, the more accurate it became. I wasn't able to overfit the model even when I tried, because I think the training data set was just so large. Here you can see what the features we were using. So that maybe the most important feature was how many reservations we had by the prediction date. And you can see that that's a number from the curve on the right, the blue curve or the bookings curves. And then the next feature is how many reservations we had on the comparable date, so the previous Saturday, the next one. And that's from the graph on the left. So you see how we are combining these two different approaches. Then the next one is just the interaction feature, number of days to the departure multiplied by the best feature we already had. But for example, here's one interesting one, this kind of work and business customer share. So that's actually output of a completely different machine learning model. We used some questionnaire data where we asked what the purpose of your trip is, and then we built another machine learning model to predict that purpose of the trip and just store it to the database together with all the data related to that same order. So we can very easily use it as a feature in another model or any analytics we do on the data. Right, then you might want to know how accurate is this model. Well, here's the curve on the training and test set. So what we did, we split the data. We have 3 different sets. So we have most of the data is the training set. Then previous 1 week is always in the test set, and then all the data after the prediction date or the current date is in the future set. And for the future set, we don't know the right answer yet. So, but we also want to measure the error on that set, but we'll get back into that later. Here you can see that the farther the train departure is, then the more inaccurate the model becomes, which also makes sense because you have less data available. And on the y-axis, the error is around between 10 and 20 passengers, which is fairly good when there's on average 140 passengers on the train. So it's like a 10% error. Right. But okay, this is how it worked in the development environment, and now we'd like to get our model to production to kind of get some results on it all the time. So this is how we deployed it. So far, we've been only working here on this data science platform, which is EC2 instance. In this case, all the data, you can fit all the data to an EC2 instance and to a pandas data frame. Just make sure you have like 60 gigabytes of memory on your instance, but still there's no reason to use Spark or anything like that. We have all our data in Snowflake. So we got the data to the Jupyter Notebook directly from there. And then trained the model, evaluated the test set, so on. And when we were happy with the model, we could store it to S3. And what you also, in addition to the model, you need to store the code which calculates the features. Because maybe in the future you want to make some changes to the features or remove or add new features. And in that case, if you don't have the code you initially used, you can't use this stored model anymore. So we store the different versions of the code to our Git repository. And also one strength of this thing is that you can have multiple versions of the same model at the production at the same time. And then you can first see how well the new models perform in production environment, and only after that you can actually make the switch that the predictions of the new model are used for the actual business decisions. Okay, then every day we want to run these predictions again. So this is batch processing, and we use CloudWatch to schedule the events and start an instance, a container on AWS Batch, which uses all this that was already stored to kind of calculate the predictions. It gets the data from Snowflake and stores the predictions back to the data warehouse. And then the last tool we used was Power BI to first make the to give out the predictions for the people making the decisions on adding the new wagons or adding the new conductors. And also we have some notebooks for the data scientists to model how well the model performs. So as I mentioned earlier, you need to really measure how well, what's your error on the, let's go back to this slide, what's your error on this future data set, because that's what really matters, and that's what we use this model performance notebook for. So next I'd like to show you just a quick demo what you can do in these notebooks. Like a couple of presentations earlier in the presentation of HZM, they mentioned that this is kind of an issue that there isn't that kind of ready-made tools for this. So here's my try of making my own tool for it. But if you know any good tools for this, please let me know. A lot of this stuff is based on this blog post or kind of rules of machine learning from Google, which gives you really good instructions how you should measure this serving error. But okay, let's get to the Power BI. Here we go. Perfect. So here you can see all the different models that I have trained. And here's one that was first trained on 19th of February. You can see that was the first run of this model. And you can see here the same curve of the training set and the test set you already saw on the slides. But in addition to that, we also have the error on the future set. Oh, okay, this is, oh, right. It's only on my monitor. That makes sense. Let's see if we can move it there. Yes, very good. Thanks. Let's see if I can find this button. Oh, never mind. It's right here. It's right here. Right. Okay. So yeah, here you can see the same curve on the training set and on the test set. I chose this model, and here you can see when this run was made. And now you can also see that I ran it again a couple of minutes later, and then a little bit later, and then it was run in the middle of the night in the batch processing. And so maybe we can check how it did in the production environment. So let's just click on that. There's no longer a training error because it wasn't trained. It only calculated the predictions. But there was still this test set which was evaluated. And on the test set, the error is same as before. So that was pretty much expected. But then after waiting, this model only predicts for the next 5 days. So after waiting for 5 days and getting the data for the actual future set, it was to kind of doing the real predictions for. Then I got this graph here, and that makes me a little bit worried because, well, here the error is around 10 passengers again, but for some reason this 3-day prediction and 4-day predictions are much worse. So they are more than 20 passengers on average are the kind of error of the model. Now, I think that here the reason is that we made a change to the output column after this model was trained, and this is probably the weekend here, and because of the change we made, there's more error during weekends. And but yeah, it's very important to monitor these and make sure that if there's some difference between the training error and the serving error, then you understand what's the reason for it. Let's try out something here. Let's just click on this. Let's remove this filter first so you can see all the different runs. It looks a little bit messy here maybe. Let's move on this another model which was trained just a few days ago. It's predicting for 80 days instead of just 5 days. and you can see that the test error graph even look very interesting. And here in the future set errors, well, I'm not really sure. It doesn't look very good. So maybe it seems that these most recent runs are not performing very well. So maybe when I get back to the office, I should make a check on this model and why the results look like this. Okay. So maybe another thing I will try to show you is then what's the output. I'll just show it to you quickly. This is the kind of outcome of our work. You can see that these are trains leaving. That's tomorrow, and the model is just testing that we should have one less conductor on this train because of the passenger count predictions. And this is something that hopefully people at the office today are looking. Maybe okay, that might not be that bad because the prediction is only a little bit over 300. So if the 300 was the limit, maybe they don't really need to kind of add the new conductor. In this case, it's not that urgent, but hopefully they are using this tool to kind of make these changes. Okay, let's get back to our presentation. So you saw how we measured the error for the future. I think that's the most important thing, instead of not just doing the test set, but also getting the serving error. Okay, but here's my last slide. This is what I would really like you to take away from this presentation. So first thing you saw, we got the data together and we trained our first model, and then we checked the error on the test set. And here you could maybe then think about, okay, maybe I should try the sequence-to-sequence neural networks. I'm sure that I can get a smaller error if I use those. And to a certain limit, you can do that. You can always try the better models and improve your error. But instead of just spending too much time in this loop, at some point, sooner or later, you should move to the next part, which is getting the model to run in production. And it's good to do that as soon as possible, because in production, you could get some new problems which you didn't have in your development environment. For example, we had a lot of issues with having enough memory for instances. So maybe you would realize that if you want to run it in production, you can't do it in Pandas and Python anymore, but you need to use Spark. And then maybe you can't use the libraries you wanted to use for machine learning anymore, because you have to move to a different environment. So that's why it's important to get here early to kind of get to know what the problems are that you face in the production environment. Then after it's in the production, what I showed you is to monitor how well it performs there. And for example, in our case, we had a data leak. So one of the features sometimes had the right answer to the regression problem. And of course, that gave me really good test and training error, but the serving error was terrible. And I could see it very quickly on the graphs that I showed you earlier. And yeah, maybe the model that you found here in this loop is not really a good model, because it's just using some features which have a data leakage. And again, you would then have to go back here and tune your hyperparameters again and so on. And after you have fixed your data leakage problems and monitored the model and you can trust it, last thing, of course, is to then give it to the end users. And in my case, I got some feedback. Oh, these numbers look really good, but could you add the people traveling with the season ticket here? Or I don't even remember. I had to make a lot of changes how the output column is calculated. As I showed you earlier, that was maybe the most difficult part of this project, was to calculate how many people actually there was on the trains in history. And there's many ways to calculate it, and only with the feedback from the end users, I was able to figure out what I really need to do. And at this point, you might have to go all the way to the beginning and get the data again. Of course, you don't need to do all this work again. Hopefully, you have some way to automatically evaluate different models, or maybe even tune some hyperparameters automatically. But anyway, you need to go through this whole pipeline again. And that's kind of my advice for you, not to get stuck in this loop here, but try to get this whole pipeline built as soon as possible, and then you can go back and maybe improve. Maybe if you really need more accuracy, try out better models there. Yes, so that's That's everything I had. Thank you.